On episode 144 of the 40 Plus Fitness podcast, we meet with Josh Mitteldorf and discuss his book, Cracking the Aging Code. The show notes for this episode can be found at 40plusfitnesspodcast.com/144. Have you decided you're ready to make a change? To reclaim your health and fitness? The 40 Plus Fitness podcast is here for you. I'm your host, Alan Meisner. I'm an NSAM certified personal trainer with a specialization in corrective exercise and fitness nutrition. Let me be your coach as you find your way on your health and fitness journey. All right, let's go. I'm so glad you joined me for this interview. We're meeting with Josh Mitteldorf, PhD. He is a theoretical biologist who runs the website agingadvice.com. He's been a visiting researcher and teacher at various universities, including MIT, Harvard, and Berkeley. If you haven't signed up yet, there's still time to join us on the 30-day Sugar Detox Challenge at 40plusfitnesspodcast.com/challenge. Now let's talk with Josh. So Josh, welcome to 40 Plus Fitness.
Alan, thanks for having me.
I'm really excited to have you here because, it's funny. I first got into your book and it felt like I had jumped into the deep end of the pool. And I mean that in a kind way because it was one of those books that immediately you have to start thinking. You can't go through your book without kind of opening your mind and saying, okay, I need to listen to what this man is saying and I need to wrap my mind around it. And I might not agree with everything he says, but it's deep. And it's something that's going to challenge me to understand myself, understand our species, understand everything about us just a little bit better. And so I really appreciate the opportunity to, one, to read a book that had me thinking the whole time I was reading it, and two, to meet the man who made it happen.
Well, thanks, Alan. I don't think this stuff is complicated. And in the book, I really try to present it as simply as possible. But it is new. And it requires overturning things that you've assumed for a long time were true. And maybe putting all your knowledge back together, like take all the puzzle pieces apart and put them together in a different puzzle.
And I think that's part of it is, it's funny. One of the kind of the paradigms that I'm kind of wrapping my mind around on the nutrition front is there's a conversation about paleo and how our ancestors ate and all those other things that are going on. And I'm thinking, well, wait, my ancestors lived in Northern Europe. I had the DNA test done, and I can tell you I'm, other than the 2.8% Neanderthal that they like to tell me I have, the rest of it, all of it is coming from Northern Europe, which effectively tells me that, my ancestors probably all ate a very similar diet, and it probably existed predominantly of leafy green plants when they're available, fish, and probably some game animals that they were able to eat. And so, other people that would be born of a different race or geography would potentially have been eating something entirely different. And so when people start talking about, what paleo really should be or what these things should be, I think the more that you wrap your head around kind of how evolution works, how all of this stuff goes, is that, we develop certain traits, we develop certain abilities based on what is presented for us. And, your book really kind of gets into a lot of the evolution and the theories behind it and the theories of aging. And I really did, like I said, I just really appreciated that opportunity. And you did, quite frankly, present it in a very clear, articulate discussion, which again, just was awesome. And I really appreciate the opportunity to have this conversation with you.
Well, thanks, Alan. To dive right into the central point of the book, the whole premise of the paleo diet is called into question by the central theme of my book. And so let me introduce what I mean by that. Why do we think natural is good? We think natural is good because we're giving the body the foods that we're evolved to deal with. Our bodies are evolved to work well with a certain set of foods, maybe with a certain set of living conditions. And that evolutionary argument is the whole basis of natural, and it's certainly the basis of the paleo diet. And what you can do with that is if the body is off track, perhaps it's off track because the modern environment is not the environment that the body was evolved to deal with. We certainly weren't evolved to eat Hostess Twinkies, to rise up with electric lights at the same time every morning, to live in polluted cities, to spend most of our day sitting behind a desk, all those things. We're not evolved to deal with that. But here's the crucial point. Aging is not the body going off track. Aging is not something that goes wrong. Aging is programmed into our genes by evolution. So all that we do to restore natural conditions, to give the body the best shot with a paleo diet, to get toxins out of the diet, the best we can do with that is to get the body back on track. But what if back on track means self-destruction? If back on track means aging rapidly and the body destroying itself? That's what aging is. It's not something that goes wrong with the body. It's exactly what we were designed for. And that's the reason that the paleo diet, natural foods, they have their place, but they have nothing to do with the diseases of old age. They will not do anything to prevent cancer, heart disease, or Alzheimer's disease. So that's really the most radical message of the book, and we can take it in many directions from there.
Well, it's not so radical, because I think doctors more and more, science more and more is effectively showing that inflammation is kind of a key component of us effectively shortening our lives. And you kind of get into inflammation in the book, and I think you say it's something like the core of like the top 3 killers. Do you mind taking a little bit of time to talk about inflammation in that perspective? And then also, you kind of also take that into a realm of arthritis. And I think a lot of people think that arthritis is kind of a disease where people are wearing out their bodies. But you really believe that inflammation, or at least that's what you propose in your book, is that really inflammation is kind of the key to what's killing us and to what's potentially causing us to feel older through these other diseases.
So the idea that inflammation is turned against the body, this is radical and it goes against the evolutionary biologists. My idea is that inflammation does its job when we're young to protect the body, to attack invaders, to destroy damaged cells and help us heal from a wound. Those are legitimate functions. I like to call them legitimate, of inflammation. But as we get older, aging co-opts the inflammation function. Inflammation is now turned against healthy cells, and inflammation becomes a self-destructive process late in life. So that's the radical message that the evolutionary biologists don't want to hear. But it's also a message that doctors, medical researchers, gerontologists have figured out long ago, that inflammation. So the clinical message, or the message for self-care, is not at all radical, right in the mainstream with this. Inflammation is the central cause of the 3 big killers of old age: Alzheimer's, heart disease, and cancer. It's closely related to all 3. And as you say, arthritis used to be divided into osteoarthritis and rheumatoid arthritis. And one, well, that's an autoimmune reaction, the body turning against itself by mistake. And the other is just wearing out with age. But the more we look at osteoarthritis, the arthritis that we get as we get older, the more it looks just like rheumatoid arthritis, except a later stage in life. We all start to destroy our bodies with inflammation as the body gets older. That's what the body is programmed to do. So this loss of cartilage is not because it's wearing out. Of course it wears out. I mean, there's wear and tear on the cartilage every day, but there's that wear and tear when you're 20 just as much as when you're 60. But when you're 60, the cartilage is not rebuilding itself because the stem cells are slowed down. And also the inflammation process is destroying the cartilage that much faster. So you have this imbalance in both directions. On the one hand, the rebuilding is taking place more slowly. On the other hand, the destructive process is taking place with a vengeance.
Yeah, and the reason I know that you're right, I know you're right on this one, is in working with clients, and I'll talk about one in particular. His name's John. And in dealing with John, I told John, I said, okay, look, I want you to just cut out sugar and drink more water. And I knew that would reduce his inflammation. He expressed to me, he had concerns because he had injured his knee when he was younger. He's like, I really still have problems with my knee. And I'm like, well, I do want you to squat. Squatting's important. If you can't get up from a seated position when you're older, you're going to lose independence. And that's something that's very important to you. So we are going to get you squatting. Maybe not with weight initially, but we're going to get you squatting. And he was really concerned about that until he cut the sugar. And then he cut the sugar, he started drinking more water, and just those two functions cut his inflammation, which is my theory, and it kind of fits with what you're saying. And, of course, when you cut inflammation, your body almost immediately starts flushing some fluids because it doesn't need those fluids to deal with the inflammation. So he lost weight very, very quickly. And he said, I can squat with no pain. And this was literally in a matter of weeks.
Well, that's a great story, Alan. And on the one hand, I want to encourage everybody, sure, a high carb diet is inflammatory. Having extra fat on your body is inflammatory. So cutting carbs out of your diet, cutting sugar out, and losing weight can decrease the inflammatory burden on your body. I want to encourage that. It's all for the good. And I also want to remind people, it works for some people, it doesn't work for others. And you just don't be disappointed or discouraged if you try something and it doesn't work. I mean, certainly try this. If you're able to cut out sugar, I think it's a wonderful thing to do, but it doesn't work for everybody. Our bodies are so different, and we end up having to experiment on ourselves and see what works.
Yeah, and that's kind of what we were talking beforehand. It's like, I know that my ancestry comes from Northern Europe, and so for the most part, there weren't tropical fruits available. So I know my body doesn't tolerate sugar nearly as well as maybe someone else would. And so, yes, a self-experiment to understand, how your body reacts to food, how it reacts to different things. And there are markers you can get in your blood work to actually tell you what your inflammation levels are. And I can tell you now, the way I eat now versus the way I was eating before, I see those blood markers getting better. And so that's the function of just self-experimentation and understanding how your body reacts to what we put it through inflammation. Now, you did get a little radical on me here, and I appreciate that because you taught me something that I'm going to have to do a whole lot more work on. But I want you to start me down this path of, there's this theory that free radicals are a function of a problem within our body, and we need to be eating antioxidants or taking antioxidants as a function to improve our health by, reducing the free radicals. But you kind of opened my mind a little bit, at least have me thinking that might not be so.
The free radical theory started out in the 1960s. It made a lot of sense theoretically, and because of that, it really caught on. I don't think your listeners really need much introduction to that. You know what the free radical theory is. The energy in our bodies is generated in tiny organelles. Within every cell, there are hundreds, even thousands in the muscle cells and brain cells of energy-generating factories called mitochondria. And they use high-energy molecules. Instead of these soft, low-energy covalent bonds that characterize most organic molecules, they use high-energy ionic bonds. And the electron transfer, I guess is what it's about, moving charge from one place to another is very energetic. And because these bonds are so energetic, the molecules are able to corrode the delicate structures of biomolecules. And of course, this happens. And the idea by Dedham Hardham in the 1960s was really a big step forward. And a very attractive suggestion that maybe aging is caused by the attack of these free radicals generated in the mitochondria on the delicate biomolecules. But this led to antioxidant therapies, the whole industry of antioxidants, and it just hasn't worked. In one experiment after another, we've tried to extend the lifespan of animals with antioxidants, and it hasn't worked. The biggest experiment in humans was with antioxidant vitamins in the 1990s in Finland. And experimenters had tens of thousands of people online taking antioxidant vitamins and had high hopes for the results. But within a few years, it became clear that the people taking the antioxidants were actually dying faster than the people who weren't taking the antioxidants. It wasn't just that the antioxidants weren't doing any good. They were actually accelerating aging in the body, at least as we can determine it by their mortality. They were dying faster. And within a couple of years, they called off the experiment. They said, we have to stop this experiment. We don't know what went wrong, but the people taking the antioxidant vitamins are actually dying faster, and we can no longer in good conscience continue the experiment.
Well, do you think that was because they were dealing with vitamins versus trying to get the antioxidants through real food?
No, I think it has nothing to do with that. Certainly, start with the fact. The fact is that antioxidants don't work. And when I say that, I want to draw a little box around, make an exception around glutathione. There's good evidence that glutathione and NAC, which is a precursor to glutathione, may have real benefits. That's the only antioxidant that I recommend.
Those work in the liver as far as detoxing and that type of thing, right?
I didn't know about that, so I'm happy to learn that from you.
Okay, that's what my thoughts were when I've heard people talking about glutathione or taking glutathione as a supplement. It was predominantly because it's a function of the liver that helps the liver detox a little bit better. There's actually, I guess I was listening to a podcast. It's kind of weird. Where I stored this, but it basically said taking glutathione when you know that you're going to be drinking alcohol might actually help you detox that alcohol a little bit better.
Oh, that's great to know. No, as I understand it.
I don't know that it's true. It's, again, it's the internet and somebody said that. But it's just kind of one of those little things you file around in your file cabinet in your head, and it just kind of bubbles around when you hear that word again. So I'm not going to attest that that's a true statement. I just know that's what I heard on a podcast.
Just to be clear about this, I don't think you can eat glutathione. It doesn't get through the digestive system.
Okay, I think they were using basically a packaging of it.
N-acetylcysteine is the standard way to increase your glutathione. And there is also packaged with lipids in some way so that it makes it through the digestive system.
That was basically the premise when they were on that podcast of why this particular product that they were kind of pushing was better. But again, they were in fact pushing a product they manufactured. So you got to take that with a grain of salt.
So glutathione is the exception. In general, antioxidants don't work. And that's the fact. Why is that? I have an idea about why that is, and I'm not alone in this idea, but it's far from proven. Let me just put out a theory that may or may not be the reason why antioxidants don't work. The body uses these highly oxidative, reactive oxidant species, ROS, as a signal of stress. And under stress, the body responds and overreacts and actually does a better job of repairs itself to a condition better than new. Hydrogen peroxide is really the standard reactive oxygen species in the body, the biggest one. And in addition to being a molecule that, yes, does damage, it's also a signal that gets the anti-aging mechanisms going, gets them into motion. For example, when we exercise, the mitochondria are going full speed and in overdrive. They're generating lots and lots of these ROS. And yet exercise has it's called a hormetic effect. It means that the body is overcompensating. Yes, we're doing more damage with these ROS generated during exercise, but the body's defenses turn on so strong that it more than makes up for that. And we end up better off with the stress of exercise than we were without the stress of exercise. So this is a clue as to how the body works. There's this tendency to overreact. There's a spare tire. There's extra ability to protect the body that isn't used in normal circumstances, but that's pulled out when there's stress. And as I say, it overcompensates for the extra stress so that we're actually better off with the stress of exercise, with the stress of starvation, even certain toxins and radiation. The body is better off with them than without them. So why is it that antioxidants don't work? I think what's happening is that they're suppressing the signaling mechanism in the body that turns on the natural anti-aging mechanisms. The signaling mechanisms are deeply connected to hydrogen peroxide and to the oxidative level in general. And when you turn down the oxidative level, the body just turns off its anti-aging mechanisms, stops repairing itself with the efficiency that it knows it's capable of.
That's interesting. Like I said, this is kind of an area that's new to me. I've not heard this theory on your side as well. So again, it's kind of one of those things of me saying, I need to do a little bit more research to get a little bit better understanding of it. But it makes perfect sense that, I know that, they'll tell you, okay, if you end up with DOMS, which is delayed onset muscle soreness from lifting weights, you don't necessarily want to take an anti-inflammatory or, a pain pill to get past that pain. You want that to be a natural course of letting your body do what it's supposed to do to repair itself, naturally. And that would be a better approach to gaining strength, gaining muscle mass than trying to get past the pain and keep moving.
So that's a story I didn't know, and I'm really happy to know about it. The story I did know is that people have been finding, just for the last 10 years or so, that the adaptations that the body goes through with exercise are suppressed when we take antioxidant vitamins. And especially when you're exercising, you have to be careful. Even CoQ10, vitamin C, the antioxidants that you may be taking as antioxidants or for other reasons, they interfere with the repair of the body and rebuilding of the body that's triggered by exercise.
Okay, cool. This is, like I said, what I really appreciate about your book is it's just kind of one of those things where you have to open your mind a little bit to kind of get through and talk about it at that realm, because it goes against a lot of the dogma that we've been told year in and year out of how we're supposed to be and what we're supposed to be doing. Like you said, we don't necessarily want to go on the Twinkie diet, but there are some things for us to consider as we kind of go through how we want to optimize our health. And that kind of takes me to the last part of this is, I wish we were trees and we lived forever, or almost indefinitely, unless lightning strikes us and then we split and die. But trees don't age. It was one of the principles, but we do. And the reason we do is sort of an internal clock that's basically our body breaking us down. Our body is effectively destroying itself. And so that's the principle. And you in the book, you highlighted 4 ways that the body effectively destroys itself. Would you mind taking a little bit of time to get into those 4 ways and then kind of leave us with a few strategies of things that we can do to stave that off, for lack of a better word, to live a better life or live a little longer, have some more longevity today?
So maybe this is a good time to put in a plug for my website, agingadvice.org, where I go into more detail with my advice for how to live a longer and healthier life. agingadvice.org. And yeah, this is on there. The 4 ways that the body destroys itself with age. They are inflammation, the immune system turning against itself, apoptosis, which is cell suicide, and cellular senescence, which is loss of telomeres. And I'll go through them one by one. Actually, inflammation we've already covered. Inflammation is a vital defense when we're young, but it turns against healthy cells. And it's the primary association with all the diseases of old age. Immune derangement is what I call the second one. So we have this system of white blood cells that are programmed to attack bacteria and invaders and to not attack any cell type in the body. Well, how are they so smart? How do they know how to do that? There's a tiny gland called the thymus at the base of your neck in the front. And the thymus gland is the T in T cells. T cells are the type of immune cells, white blood cells that do this. The thymus gland is the training ground. White blood corpuscles, as they mature, go through the thymus and they learn, this is self. You don't touch it. You protect it. They're the good guys. And anything else is an invader, and you attack them with a vengeance. And it works great. It works great when we're young. The thymus gland grows as we mature. It reaches its maximum size when we're about 10 years old, and it starts to shrink. As it we get past age 50, it's really shrinking and disappearing. And not only that, some of the functional thymus cells turn to fat cells. By the time we're 80, the thymus really isn't working very well. And the immune cells make two kinds of mistakes, which statisticians in their creativity name type 1 and type 2 errors. This is really what they call them. Type 1 error is you didn't do your job. Type 2 is a false positive. You're over-aggressive, did something you weren't supposed to do. So we get both kinds of mistakes in the T cells as we grow older. On the one hand, the white blood cells are not doing a good job of protecting us from invaders. And that's why a 90-year-old dies of pneumonia when 20-year-olds almost never die of pneumonia. The flu, when the flu comes through, a lot of old people die, and the young people get the flu and survive. And the other kind of error is that these immune cells are turning against the body, attacking the body. It's connected to inflammation because when the T cells latch onto something, it incites inflammation at that site and calls in inflammation to do the job of finishing off the cell that's attacking. And the cell that's attacking is often you, healthy cells in your cartilage, healthy cells in your muscles, healthy nerve cells. The third auto-destruct mechanism is apoptosis, apoptosis. Sometimes it's called, there's a P in there that's sometimes pronounced, sometimes silent. And this is programmed cell death. We absolutely need programmed cell death. When our bodies are developing in the womb, we develop as sort of an undifferentiated lump, and the shape of the body is sculpted by the cells that aren't needed disappearing with programmed cell death. When our brains are developing, we get 10 times as many nerve cells as we need. The neurons generate huge numbers of neurons, and then the ones that aren't needed die off, leaving a functional brain.
For most of us, yeah.
I mean, you never imagine, when you imagine that the body grows up by sort of being built up the way you would build a clay sculpture, not the way Michelangelo carved David out of a solid piece of stone by eliminating the stuff that isn't needed. But apoptosis has a lot to do with development. Apoptosis is also important in cancer. As soon as a cell detects that it's losing its grip on its real function and it's in danger of becoming a danger to the body, apoptosis sets in and the cell falls on its sword. It digests itself, turns itself into food for the neighboring cells. It's a very orderly process, apoptosis, and it works really well in young people. And as I say, we need it to ward off cancer. When a cell is invaded by a virus, the cell again detects that it's sick, it's a threat to the rest of the body, and the cell will commit suicide. It works really well. We can't do without it. But as we get older, apoptosis starts to be on a hair trigger, and healthy cells start to disappear. Sarcopenia is the fancy name for muscle wasting. I'm sure all you listeners are familiar with the fact we just aren't as strong as we get older. The muscles disappear and slowly turn to fat. The disappearance of muscle cells is apoptosis. They're bowing out through cell suicide, even though they're healthy and useful cells. It's also, we're beginning to find that the loss of nerve cells associated with Alzheimer's disease is connected to apoptosis. So healthy brain cells, useful neurons, are killing themselves with programmed cell death. You really couldn't get a more stark vision of the body destroying itself on purpose than apoptosis. So the fourth is cellular senescence, telomere shortening, and it's become enough of a headline grabber that your listeners probably have heard some of this story before. The telomeres are tails on the ends of chromosomes that get shorter each time the cell divides, and it serves as a kind of clock inside the body, because when the telomere gets too short, then the cell goes into panic mode. It becomes very destructive of the surroundings. So when we're young, we're born with long telomeres. Telomeres are extended in the womb from the length that they were when we received these cells from our parents. But for most of the rest of the life, there is no capacity or very little capacity to maintain the telomeres. So they gradually get shorter. Each time stem cells produce new cells, their telomeres get a little bit shorter. And this eventually becomes a problem as the cell goes into a senescent mode. A senescent cell not only isn't doing its job, a senescent cell is spewing out inflammatory signals that cause other cells nearby to become senescent and cause other cells nearby to send inflammatory signals through the body, turning up in inflammation. So it's a connection with number one. There are some people who are saying that telomeres are the body's primary aging clock. That's how the body knows how old it is. And others who say, well, maybe it's secondary. There's only a small part of our aging that's accounted for by telomeres. I think the jury is still out on that, but there's definitely a role to play. Longer telomeres are protective. Shorter telomeres are a threat as we get older. And again, this is it's programmed into our biology that the telomeres get shorter as we get older.
Okay, so now we have these four enemies standing in front of us. What do we do about it?
yeah. It's a let's just give a hint and then send people to the website and to the book. Inflammation. You can use an anti-inflammatory diet, which is low carbohydrate, low insulin. Keep your insulin sensitivity high. Keep your fasting blood sugar low. There are anti-inflammatory herbs. Ginger is good. The best known may be turmeric and the ingredient curcumin in turmeric. NSAIDs, for most of us, it works fine. For some people, it irritates the stomach, and you have to be careful if you're one of them. But the simplest thing you can do is just take a quarter aspirin at bedtime.
Exactly what my doctor just told me yesterday. He's like, just take baby aspirin. You need to start taking baby aspirin. We're not really happy with your triglycerides and, some of your inflammatory markers right now. So why don't you start taking a baby aspirin? Okay, that's what I read. That's what I read in the book. Yeah.
I'm gratified that a lot of this turns out to be standard medical advice. So what can you do about the immune system? The shrinking of the thymus, there's experimental therapy going on now with growth hormone, with a blood factor called FOXN1. It's not here yet, but it may be that supplementing with DHEA has some effect on slowing the decline of the thymus. And there's an herb that I like called charnushka or kalunji, or black cumin seed, depending on what culture you come from, that may have a benefit for preserving the immune system. There are also reishi mushrooms from the Far East seem to have a protective effect on the immune system.
Since we're talking about immunity, what are your thoughts on echinacea? Because I know a lot of people will take that, particularly around cold and flu season, as a means of bolstering their immune function. Is that something that affects the thymus that you're aware of, or have you done any work?
I don't know about any studies connecting echinacea to the thymus. I've experimented with echinacea. I'm not sure that it works for me, but I've heard enough other people say it works for them. Again, I'd encourage your listeners to experiment and see what works in warding off a cold in the early stages. See if you can nip it in the bud.
And then now apoptosis, which I can tell you personally is get in the gym and lift heavy weights, because that's going to, it's going to spur your testosterone. Man or female, you will slightly increase your testosterone by lifting heavy weights. You will and can slow sarcopenia if you're willing to get into a progressive lifting program.
Yeah, that sounds great. And the corresponding thing for the brain is, as we keep active, as we learn more things, learning new things, changing your mind as you grow older is the best protection against Alzheimer's disease.
That's why I was glad I had the opportunity to read your book, because it's kind of one of those things. Yeah.
Yeah. Just absorbing the new material of the book is anti-aging in itself. But this is a tough one. I know of no drugs that attack or supplements that attack apoptosis.
Well, there are a lot of studies where they talk about neuroplasticity and your opportunity if you do new things. I interviewed Dr. Gary Small not long ago, and I kind of said to him, I said, he had a Sudoku in his book, an actual Sudoku puzzle to do, and I did the puzzle, And I told him, I said, I fly through Sudoku puzzles. So I don't even do them anymore. And he says, well, have you ever considered trying to make a Sudoku puzzle? And I said, well, no, but I set up that night trying to make one, and it's harder than you would think. It seems like it'd be a very easy thing, 9 numbers in 9 boxes and make them all work. It took me longer than I thought. It took me about 4 or 5 hours to actually do a Sudoku puzzle. And I actually have that published on my website at older.fitness/Sudoku. But, to someone challenge me to do something, I'm going to do it. And, again, it was kind of one of those things of I was using my brain. I was thinking through, why, because I tried something. I'm like, okay, that didn't work. Why didn't that work? And so, I think using something, it's kind of the use it or lose it mindset. I think that's really a true maxim, particularly with apoptosis. I think that's really our opportunity is if you don't use it, your body's basically going to say, I don't need it. And that's its opportunity to get rid of it.
Yeah, I'm all for that. And the kind of exercise that is most beneficial is the kind that hurts. It doesn't take a lot of time, but it's really intense. Exercise for the muscles where you're straining the muscle to capacity and you lift to failure, they say. And aerobic exercise to the point where you're just in a minute or 2, 3 minutes at most, you drive yourself to, you're just panting and you can't take it anymore. You're running faster or working out faster on the elliptical or in the pool, sprinting as fast as you can and developing that oxygen debt so that you're panting uncontrollably at the end. You can do it in 1 minute and do that several times a day. It takes a lot of willpower to get you to do it, but it's the most effective kind of exercise.
Now, you gave me a website earlier. You called it agingadvice.com?
.org.
.org. Okay. I'm sorry. .org. Agingadvice.org. And then the book is obviously Cracking the Aging Code. Is there anything else that you would like for us to check out while you're here?
I have a blog that's agingmattersblog.org. You can also get it through scienceblog.com. I'm one of the set of bloggers associated with that website, scienceblog.com. Or you can reach it directly at agingmattersblog.org. And every week or so, there's a topic from the news that's of interest, some of it peripherally related, some of it theory. But there are many health-oriented articles in there.
Awesome. Well, again, Josh, I really appreciate you coming on today. And, again, the book, Cracking the Aging Code, was kind of one of those things that I really had to think through. And it was like brain candy. And I really appreciate it. So thank you.
Well, thanks for doing your homework. I really appreciate talking to people who engage with what I've written. It's just so gratifying for me. I'm 67 years old. This is the first real career success that I've experienced. I'm 5 years older than my father was when he retired from his business and started being an environmental activist. It's a wonderful thing for me to see these ideas get out there, to hear people engage with them. And I appreciate you, Alan, for having done your homework and knowing just what to ask and being right there with me as we discuss these questions.
Well, again, it's a fascinating topic, and I was just glad to have an opportunity to talk to you.
Well, thank you.
I'll admit, Josh has me wondering if things we think we know might turn out to be wrong, especially the bits about antioxidants. Next time on the 40 Plus Fitness Podcast, we'll get into yoga's healing power with the author, Allie Hamilton. Until then, have a happy and healthy day.